Okay, welcome to the last section of Chapter 6. And this is called Infinite Series. And so basically we want to talk about what happens when a series goes to infinity. And I'm just going to bring up a little picture here to show some different scenarios. So one possible thing that could occur is that the sum could increase without limit. And that would be something like you see here, because what's happening is this is like an arithmetic series. When you keep adding, it could be a geometric series also, but if it's just continuously heading up, 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 and you're adding and adding and adding, then you're just going to increase without limit. The number is going to just keep getting bigger and bigger and bigger. Okay, so another thing a series could do is decrease without limit. And that's what you see in this picture here. And so this would be a situation where whatever your equation is producing values that continuously are getting bigger and bigger, but in a negative direction, so that when you sum them, you're going to be continuously getting a bigger negative number, or you could say a smaller number. So decrease without limit. Okay, another thing that could occur is we could have the series approach a limit. And that is what you see happening in this situation. So this is going to be some scenario where your numbers at some point start not changing very much in your particular series. So the actual sum is going to approach the limit, and that's going to be the main theme of what we're going to talk about in this section. There is one other thing that could occur. I'm not going to do an example, but another thing that could occur is the series could do what we call oscillate. And when things oscillate, what happens is they might go to +1, then go down to -1, then go to +1, then to -1, etc. So that's what we call oscillating. Sort of the situation of going up and down, up and down, up and down. Okay, so now let's look at some, well, not in examples, but let's talk a little more specific. So, an infinite, I should say, arithmetic series has no limit. So if you have some sort of a series where we have a summation and it produces values, I'm just not going to worry about what the actual equation is, and it's going to infinity, and it produces values like this: 2 plus 4 plus 6 plus 8 plus dot dot dot. You can see that it's just increasing, and it has no limit. So when it's infinite, when the series is going to infinity and it's arithmetic, as in we're adding the same number each time, it will have no limit. So the number will get really, really, really big. Your sum will get really big the further out you go into that series. Okay, an infinite geometric series has no limit when the common ratio, and I'm going to say it's the absolute value of the common ratio, is bigger than 1. So what do I mean there? I'm going to just do a similar sort of a picture of this. So if we have n equals 1 to infinity, and there's some equation, I'm not going to worry about the equation right now, and as long as the common ratio has an absolute value that's bigger than 1, so say I start at 2, and say my common ratio is 3. So I'd have 2, and then 2 times 3 is 6, and 6 times 3 is 18, then 18 times 3 is 54, etc. Hopefully you can see that if I'm continuously multiplying by 3, this thing is also going to get infinitely big and have no limit. So those are actually two straightforward situations. When we see an infinity and it's either arithmetic, and we see an infinity and we know the common ratio is, and another way to say this is the common ratio is not a fraction, then we have a series that's going to have no limit. Okay, so there is one other scenario that we're going to spend most of the rest of this little video on, and that is an infinite geometric series has a finite limit when the absolute value of the common ratio is less than 1. And another way to say that is basically the common ratio is a fraction. So, in order to think about this a little, I want to go back to the cheat sheet, I guess. And if you remember on the cheat sheet, we met this equation, S sub n is equal to a sub 1 times 1 minus r to the n all over 1 minus r. And if you notice, this is for a finite geometric series. So I want to explore this for an infinite situation. So I'm going to go back over here, and I'm going to write that again. So I have S sub n is equal to a sub 1 times 1 minus r to the n all over 1 minus r. Now, in order to think about what's happening when my common ratio is a fraction, I'm going to use my calculator for a second. So, when my common ratio is a fraction, so this is r in this equation, and when this n is infinity, as in we're thinking about this thing getting really, really big, what happens when we take a fraction and we raise it to a really big power? So I'm going to come here to my calculator, and I'm going to just think about taking a half because it's something simple that I can think with, and I'm going to hit my y equals, and I'm going to put a half in. I'm just going to type it in as 0.5, and I'm going to raise that to the x power. So that allows me to get my calculator to help me explore what happens when I take a half and raise it to a really big power. So I'm going to go ahead and hit second to go to my table set, and I'm going to change this to ask mode so I can ask it some specific numbers. And so now I'm going to go over to my table, and I'm going to say, okay, I'm going to put a 1 in. So when I put a 1 in, I shouldn't be surprised to see a half comes out, because if I take a half to the first power, I get a half. So then I'll put a 10 in, and I'll see what happens. So even just putting a 10 in, when I take a 10 to the half power, I get 9.8 e to the negative fourth, which, if you remember what the calc is telling me, it means 9.8 times 10 to the negative fourth. That's what the e is, which is really 0.00098. So that's a pretty small number. So let me get a little bigger. So I'll go to 100. So I'm going to take my half and raise it to the 100th power. And you'll notice what happens is now I have this 8e to the negative 31. So now I have an 8 with 30 zeros in front of it. And I'll go ahead and I'll type 1,000 in here. And my calculator, even though it's a very, very small number, it's not actually 0, but my calcs run out of space to actually write what it is. So hopefully you can see then when we take a fraction and we raise it to a really big number, what ends up happening is we come out with something that is as good as 0 because it gets to be so small. So if I come back over here for a second and I realize that, I'm just going to rewrite this equation, And I'm going to take this a sub 1 and I'm going to distribute it. So I get a sub 1 minus a sub 1 times r to the n all over 1 minus r. If I am figuring out an infinite sum, and this r value is a fraction, as in basically what I'm saying here, if this r value is a fraction, then this really is as good as 0. And 0 times anything is 0. So that term basically is going to drop out. So what we are going to say then is that this sum then is going to be equal to a sub 1 over 1 minus r as n approaches infinity. And a way to show approaches is with a little arrow. And once again, that's in situations where r is less than 1. Now you'll notice that's not on your cheat sheet. So if it was me, I might, on my cheat sheet, train myself, if I want to talk about an infinite series, when my r value is a fraction, then what I would do is I would take my s sub n and I would do the little move I just did where I distributed. So a sub 1 minus a sub 1 times r to the n all over 1 minus r, and realize that this number here is going to go to 0 when I get infinite, and so that this is really going to be a sub 1 over 1 minus r. Now I know this might feel a little confusing, but hopefully maybe a little practice and it'll make more sense. Okay, so a couple examples here. So we might see something like this. Find the sum n equals 1 to infinity of 1/3 to the n power. And so this would be something that you would need to recognize and realize, well, what does this really mean? So it means first 1/3 comes out, because that's what happens when I put a 1 in, plus, remember this is a sum. Now I'm going to put a 2 in there, so now I'm going to get 1/3 squared. And then this machine's going to keep going up and I'm going to get 1/3 cubed. And this is going to go on and on and on. But as this fraction gets raised to a bigger number, that number is going to be getting so small that it is good as calling it 0. So if someone asks me to figure out what this sum is, this is when I'm going to pull out this new equation that I just showed you, where I need to just take a sub 1 divided by 1 minus r. So what is a sub 1? In this case it's 1/3 all over 1 minus 1/3. And you can probably, the easiest thing would be carefully do this on your calculator. So when you get 1/3 over 1 minus 1/3, actually just for fun I'll do this out, it's really 1/3 divided by, this is 2/3, so that would be times 3/2, and this would then be 1/2. Guess maybe I'll do one more example. We will talk a little bit more about this in class also. So, another example. Given something like this, 2 plus 1/2 plus 1/8 plus 1/32 plus dot dot dot. Say you were asked to write this in summation notation. So write, I'll say it in sigma notation. In sigma notation. So first off, what I've said in most of these videos is I would do one of these. And when I see that dot 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 right there, that's telling me that this thing is going to infinity. So now the question is, what am I going to put here? And hopefully you realize that this is not arithmetic. So then the next question would be, well, what is going on in between each of these? And one way to do that would be to just actually pick up your calculator and say, well, what do I get when I take a half and I divide it by 2? What do I get when I take an eighth and I divide it by a half? Well, as it turns out, what you get is 1/4. So our common ratio then, in this particular case, is 1/4. So then how would I write that in this equation? Well, I'm going to take my first position 2 and I'm going to continuously multiply it by a fourth. Now, how is this going to happen? The first time I need a 2 to come out, and this might be a little tricky, but I just ask you to bear with me. In order to just get a 2 to come out, really what I need is for this position up here to have a 0, because anything to the 0 power is going to be 1. So I am going to put up here an n minus 1. Now why would I do that? Because when I put a 1 in, 1 minus 1 is 0, which would mean a fourth to the 0 power, which is 1 times 2 is 2. Plus, then this thing cranks up to a 2. 2 minus 1, that would be 1. A fourth to the first power is a fourth times 2. 2 times a fourth is 1/2, etc. Okay, the next part of this, you may be asked to find the limit. As in, where is this thing headed? And so this is the example where we would take this S sub n is equal to a sub 1 over 1 minus r. And if you take your a sub 1, which is a 2 in this case, divided by 1 minus 1/4, you get 8/3. And I think we'll play around with this a little bit more in class, but that's all for now. So I direct you to go to mathexcelforschool.com and work on section 6-7 quiz.